Introduction. By the end of this lesson, the students will be able to explain the terms reactant, product, and rate of reaction, state the unit for rate of reaction, suggest an experimental technique for studying the rate of a given reaction based on the changes that can be observed during the reaction. In a chemical reaction, substance A changes to form a new substance B. Substance A is called the reactant and substance B the product. The speed at which the reactants are converted to products gives us the rate of the chemical reaction. Click Next to start the reaction. Click the play button to observe that as time passes on, more and more particles of A are used up and more particles of B are formed. To see the change graphically, click Next. We can see the change in the amounts of A and B better by plotting their concentrations against time. Move the slider and note the change in concentration of reactant A and product B with time. What can you deduce about the concentrations of the reactants and the products during the course of a chemical reaction from this graph? Discuss and click Next. Answer. The concentrations of the reactants decrease while the concentrations of the products increase during the course of the reaction. We can determine the rate of a reaction by measuring the change in concentration of the reactant or product over a time interval. The unit is mole per cubic decimeter per second, if the time is measured in seconds. The rate of reaction with respect to the product B is written as dB over dt. The rate of reaction with respect to the reactant A is written as minus dA over dt. Why is a minus sign needed in the rate expression for A? Answer. The concentration of A decreases during the time interval, so dA is a negative quantity. Hence, a minus sign is needed in the rate expression to make the rate positive. In another reaction, reactant A combines with reactant B to form product C, as shown in the equation. Use the coefficients of the balanced equation to compare the rate of disappearance of B with that of A. Discuss and click Next. Answer. The rate of disappearance of B is 3 times that of A. What is the rate of formation of C? Click Next for the answer. Answer. The rate of formation of C is twice that of the rate of disappearance of A. The rate of a reaction is the change in concentration of either the reactants or the products with time. The unit for rate of reaction is mole per cubic decimeter per unit time. If we know the rate of reaction with respect to one species, we can determine the rate of reaction with respect to the other species in the equation. To measure the rate of a reaction, we need to measure the change in concentration of a reactant or product over a period of time. In some cases, the change in concentration can be measured by measuring an observable change in the reaction mixture. Calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon dioxide, and water. What do you observe during the reaction? Click the Start button. Answer. Bubbles of gas are given off. We can determine the rate of the reaction by measuring the change in volume of gas produced over a period of time. Click Next to see how this is done. The amount of gas collected in the syringe indicates the volume of carbon dioxide produced. Move the slider and observe. A graph of the volume of gas produced against the time taken is then plotted as shown. This graph shows how the volume of gas produced changes with time. Consider the formation of nitrogen dioxide from dinitrogen tetroxide. Click the play button and observe that 1 mole of N2O4 decomposes on heating to give 2 moles of NO2. Hence, there is a change in the number of moles of gases in the reacting vessel. How would the pressure in the container change during the reaction? Click Next for the answer. Look carefully at the mercury level in the barometer. When the reaction stops, click Next. The mercury level rises due to an increase in pressure when NO2 is formed. The rate of reaction can be measured by measuring the change in pressure with time. The equation above shows the reaction between bromine and formic acid. Note that bromine is the only substance involved that is colored. We can therefore measure the change in color intensity of the reacting mixture to help us determine the rate of the reaction. Click Next to see how this is done. A filter is used to choose the light which is absorbed by the solution under test. When light falls on the photocell, a current is generated. The current generated depends on the amount of light that passes through the solution. Click the play button and observe this. Formic acid is poured into bromine and a small amount of the reacting mixture is immediately removed for testing. Click the play button and observe that as the concentration of bromine decreases, its color fades and more light passes through the solution. The meter is calibrated to show the amount of light absorbed. Move the slider and notice the decrease in concentration of bromine with time. The concentration of bromine remaining at any time t can be determined from the meter reading and the corresponding calibration curve. Therefore, the change in concentration of bromine in a given time interval can be determined and hence the rate of that reaction. The rate of reaction can be determined by measuring the change in concentration of one of the reactants or products over time. The change in concentration can be measured by monitoring the change in 1. Gas volume, 2. Gas pressure, and 3. Color intensity.